Hey, good afternoon, class. Morning. So we're looking at exercise 1. Exercise 1 is on page 121. And we're doing problem solving in 2D and 3D. Okay, as we know that there's normally an issue. So what I'm going to do is I'm going to do each and every sum in these exercises. Alright, so we are told that you will first do a few basic examples to revise grade 11 work. So basically this is grade 11 work, okay? Just one step in the example that alluded to grade 12, which was a double angle. Okay, but then you will use a double angle or compound angle identities to find the final answer for problems. Okay, so we're looking at number 1. So here we are told that in A, B, C, D, so A, B, C, D, okay, is a building with tower DE erected on top. The angle of elevation from A to E is 21 degrees, okay, and the angle of elevation from B to E is 48 degrees. If the height of the building is 30 meters, so that of course that has to also be 30. Why? Because it's a rectangle, of course. Okay? Calculate the height of the tower. So in other words, I must calculate D. Can you all see that before? So with the information given, what can be calculated? So we got 30 here, 48. So we're shorting this to calculate the hypotenuse. But I need the hypotenuse, okay? As you can see here. But what do we have? One length. We know what's the size of this angle here? 90. So what's the length of this whole angle here? ABE. BAE. So you can say BAE is equal to 90 plus 21, which is 1. Why does it say 1? If you want, you can say that DAB is 90, because that's a rectangle, and then you conclude that. Alright, what else can we calculate? You can calculate this angle here, which is ABE. ABE, sorry? 111. Sorry about that. Okay. Again, the same thing. Okay. You can work out this angle here, which is 90 minus 48, which is 42 degrees. Is that correct? So we have a triangle looking like this now. Okay? And for those of you who have problems seeing it, I would suggest you guys write it out. So it's AEB. This of course is 42, and we have a length of 30. So remember, what did I say? What did we need? We need BE. Not so. So, do we have the angle opposite BE? Yes. Do we have the angle opposite 30 meters? No. Can I work it out? Yes. So, AEB is equal to 180 minus 101 minus, 111 minus 42. That gives you an angle of 180 180 minus 111 minus 42 gives you 27 degrees. The angle is of course 27 now. Okay. So can I calculate B? Yes. As you see all this information I have on the diagram already, I just need space. So B is what I'm calculating. BE over sine of 111 is equal to, because I got the 30 I need to use that angle there. So it's going to be 30 over sine of 27. So what do I do? I cross multiply, or I just take sine 111 up. Because the cross multiply is going to be BE sine 27 is equal to 30 sine 111. Then I divide both sides by sine 27. So BE is equal to 30 sine 111 over sine 27. Okay, so that's going to give you 30 sine 111 over sine 27. Here's an answer, 61,69 meters. So this length here is 61,69 meters. Okay, you guys understand? But have you answered the question? No. Then let's look at the other triangle now. Let's look at this triangle here, which is in triangle. ECB. What do we know? This is 48. Okay, this whole length is CE. So I can't just write 30. Okay, or you can say 30 plus x if you want. But B is going to be 61,69. Okay, so I'm going to calculate these EC. Which trigonometric function is, remember this is 90 degrees, so I can use sine, cos and tan. Which trigonometric function uses opposite and hypotenuse? Sine. So I can say sine of 48 is equal to EC over 61,69. So what do I do now? Cross multiply again. So CE is equal to 61,69 sine of 48. 61,69 sine of 48 gives me an answer of 45,85. But have I answered the question? No. The question was to calculate the height, which is DE, not so. But remember that this whole length now is 45,85. So I'm going to get the height there, I'm going to subtract the 2, not so. So therefore, DE is going to be 45,85 minus 30, which is 15,85 meters. If they wanted the nearest meter, it would be 16 meters. Is that correct? Check the answer. Sorry? Correct. Alright. What's wrong? Okay. So for homework, I would like you guys to conclude the exercise, and then in tomorrow's lesson we will do the examples. Okay. Enjoy the rest of your day. Good morning, class. Okay, good morning, class. So today we're looking at trigs, so trigonometry, problem solving in 2 dimensions and 3 dimensions. Okay. So at this point we have done number 1 already. So let's look at number 2. In number 2, we are told that A, B, C, D is a field. Okay? In the shape of a trapezoid or a trapezium. Then we are told that BD is equal to DC, which is equal to X. So there's an isosceles triangle being formed here, with BD being constructed. Then BDC is 120 degrees. So I ask you to show that BC is 3 root X. Okay, so what do we have? We have 2 lengths and an included angle. Yes, Michael? Okay, 2 lengths included angle. For those of you who don't see it, you should see something like this. That being 120, X, X, D, B, C. They want you to calculate that. Okay, as you can see, there's XT, which explains those 2 lengths, in other words. Before you tell me that, I know. Okay. So number 1, we're going to firstly say that BC squared is equal to BD squared plus DC squared minus 2BD times DC cos of angle D. Do I have to write this general formula here? No, you don't have to. Okay, but you'll see me write it often, so that by chance, when you're going to study, okay, you'll know exactly where it's coming from. Okay. So BD is X, so X squared plus X squared minus 2, BD is X, DC is also X, cos of 120 degrees. So of course that's going to be 2x squared. That is also minus 2x squared. Now cos of 120 is the same as cos of 180 minus 60. So which quadrant is this in? Second quadrant. Cos positive, negative in the second quadrant. Changing this negative to a positive. So some grade 11 3 coming into play here. Okay, so it's going to become cos of 60. But people, cos of 60, that takes you to the special triangle. There's 30, 60, 1, 2, root 3. What is cos of 60? Opposite? So adjacent of hypotenuse. Okay, so 1 over 2. So it's going to give you 2x squared plus 2x squared times half. What is 2 times half? 1, so that's gone. So what is 2x squared plus x squared? 3x squared. So BC is going to be 3x squared. What do they want? BC. So what do? Square root both sides. So therefore, BC is going to be the square root of 3. The root of x squared, of course, is x. Okay, you guys understand? Any confusion there? You guys managed to figure that one out? Okay. You're waiting for the more challenging ones, I'm sure. Saying it yourself, life can't be this boring. Let's spice it up. Right, so let's look at, so of course this is going to be root 3x. Now say for argument's sake, you didn't manage to solve this. Then what you do is you write the root 3x there and use it as if you have solved it. Okay. Then number 2, the question says 2.2. If BC is 300, so BC is 300 meters. Find the value of x. People know if BC is 300 and BC is root 3x. So what does that mean? That the root 3x is equal to 300. So I divide by root 3 both sides. It cancels, so x is equal to 300 is 100 root 3, I think. So correct. 300 over root 3. So it's 1 over root 3. Should be root 3 over 3. So it should be 100 root 3. That's when you're rationalizing the denominator. I would normally multiply that by root 3 over root 3. That's going to give you 3, and 3 goes into 3 once, 3 goes into 3 and 100 times, 100 to root 3. Or the answer that they have, which is 173,21 meters. Which answer do they have at the back? 300 over root 3. Okay, important. Okay, so or 300 over. People, if they wanted you to rationalize the denominator, they would tell you, or they would have told you to write it in simplified third form, or they would have told you to write it in 2 decimal places. However, if they didn't specify threefold, you can do anything you want to do, as you normally do. So, of course, x is going to be 300 over root 3. Okay. Let's look at the next question. Now calculate the value of angle A. So this is angle A. Okay. So I'm going to calculate N. So we know this is 60, this whole angle is 60. So the co-interior angles there. Okay, we know what x is now, no? Or AB is 200. So we don't need that 60. Sure, right? In order to calculate A, I would need to know this angle here. Not so the whole angle, then I can go with the interior angles. Okay. So that being 60, that's not going to help us. Anybody manage to solve this one? Sorry? So trapezium is. I would almost want to say you're going to calculate this angle here. With that, you should be able to calculate this angle because that's alternate. And then because we got that, and an excluded angle, can use the sine rule. But it's going to be a long way around. Isn't there an easier way? Yes? Ask. There we go, that is right. Absolutely. So you're saying that is an isosceles triangle, and this angle, of course, is equal to that angle. Nice. You saved me a trip now. Well done. 2.3. She's saying that DBC is equal to BCD, which is equal to 180 minus 120 divided by 2. Which gives an answer of 60, which is 30 degrees. And the reason there, you don't need a reason, but we use sum of triangles, that is where the 180 comes from. We have used the fact that these angles, opposite, equal sides as well. We use two theorems here. That's where the 2 is coming. Not so. So that's 30 degrees. Now, I'm going with the fact that this is alternate angles here. It's the other way around. Because I got this length, I need this angle here. So that was right here. Alternate angles. So this angle will be equal. Not so. So what when we say now is that ACB, angle ACB is equal to 30 degrees. Why? Because of the alternate angles with AC being parallel to BD. Did I have to write this here? No, unless stated otherwise, or you're busy with Euclidean geometry. It's the only time you need the reasons. If they ask you for the reason, or in Euclidean geometry. But why am I writing this? So that you guys can know exactly later on if you stop where it's coming from. So that's going to give you 30 degrees. Otherwise, I could have used the factor that is co-interior and 60 minus 30 as well. Okay. So now we've got a triangle looking like this. This triangle here, it's going to be a triangle looking like this. So that is 30. That is 300. This is 200. And they want you to calculate A. Not so. So what do we say? Sine of A over 300 is equal to sine of 30 over 200. You guys understand? So if you want, use a kind of call that want to say intra-angle ABC, you can do that. Okay. But since I'm drawing this all the time, you'll see me drawing it all the time next to the sum. You'll know exactly which triangle I'm working with. Okay. But okay, let's put here intra-angle ABC. What do we say? We say that sine of A over its length of, its opposite length of 300 is equal to sine of 30 degrees over 200. Not so. So what do we do now? Cross multiply. Let's just move that 300 up. If you cross multiply, we have 200 sine A is equal to 300 sine 30. Then you divide by 200 both sides. And you will end up with sine of A is equal to 300 sine of 30 over 3. Let's work that out. It'll be 300 sine of 30 over 200. View 3/4. So arc sine of 3/4 arc sine U 48,59. That's your reference. A is going to be 48,59. Okay, why do you think I put the reference here? Because A could have been one of two angles. This is the oblivious case, no? Why? Because this is opposite the longest length. So this could have been an obtuse angle as well. Okay, let's check the textbook. You should have had two solutions there. Does it only have one? You will only carry on. Sorry? Sorry? They used both. Okay. As I said, how do we know it's that? Because they're the unknown angles opposite the longest length. Okay. So angle A is going to be 48,59, or X is, A is equal to 180 minus that angle. Okay. Why 180 minus? Because it's in your second quadrant. Remember, sine is positive in quadrant 1 and 2. Just like your general solution you did in grade 11. Okay. That is 131, 4, 1. Okay. So I'm going to write that in there. 48. What was the two angles? A is 48,59, or 131,41. Okay. I wrote it there so that I can take this off the board again. Okay. The next question says, then calculate the area of the field. So for the area of the field, people, the area is going to be consisting of triangle ABC. The area of triangle ABC plus the area of triangle BDC. Okay, this is area then, of triangle ABC plus area of triangle BDC. Otherwise, we could have used the area of a trapezoid. What is the area of a trapezium? I don't know. It's going to be A. The area is equal to half AB plus CD times perpendicularity. If I translate this into this, remember that AB and CD is your parallel lines, the length of the parallel lines. In this case, it would have been the area is equal to half that, which is BD, which I do have, not so. I know what X is, times and plus CD. This case is going to be AC times. Now the perpendicular height I don't have, and I don't have AC. Otherwise, you can calculate AC and you can calculate the perpendicular height, which is going to take quite a bit of calculation there. Not so. So we rather just go with breaking that areas up there. You all okay with that? So how do you calculate the area of a non-right angle triangle? What do I need? I need two lengths and an included angle. Not so? Two lengths and an included angle. So do I have this angle here? No. But I can calculate that angle. Not so? Likewise in this triangle here, I have two lengths and included angle. So why can't I use A? Because I don't have the length of AC. Can you see that? Two lengths and included angle. So if angle A was 48,59, then this angle here, which is ABC, is equal to 180 minus 30 minus 48,59. Give me an answer of 101.41. So now I'm going with this area formula. Area is equal to, I'm going to use two lengths and included angle. So it's going to be half BD times DC sine of angle D plus, for this triangle here, I'm going to go half AB times BC sine of angle ABC. Did I have to write this whole story out here? No. You don't have to write it out. Okay. So I go half. What's BD? X. And what's the length of X? 300 over root 3. Times DC, which is what? Also 300 over root 3. Sine of angle D, and which is 120 plus. You go in the side. So you go half times 200 times 300 sine of 101.41. So we got half times 300 over root 3 times the same thing sine of 120, close the bracket, plus half times 200 times 300 sine of 101.41. 42,319. Check if that's correct. I'm feeling better. Meters squared. 42,397,48 meters squared. Okay. Otherwise, we'll use the other for the other one. If remember, they didn't tell us that A is obtuse or A is acute. If they had told us that, then we could have eliminated one of the solutions. Because it didn't, we have to go all the way. Okay. So if A is 151,41, then what is this angle then here? It will be 180 minus 180 minus 30 minus 131,41 gives us 18,59. 18,59. So again we go. I don't know why I took everything off. The area is equal to half. So this remained the same. So I just have to leave it on the board. DC sine of angle D plus of AB times BC sine of angle ABC. So it's going to give me again half times 300 over root 3 squared or times 300 over root 3 sine of 120 plus a half AB, which is 200 times BC, which is 300 sine of 18,59. Okay. So it's half times open brackets 300 over root 3 squared sine 120 plus half times 200 times 300 sine of 18,5 gives you 22,554,1 meters. The textbook had both answers. Okay. They should have had both because they didn't omit one of the two there. And you see it's different. Not so, it's dependent on that angle. If it's an obtuse angle, I think it was more than this, it was bigger. No? What was the previous answer? Sorry? Yeah, as you can see, it's much bigger. It's just shy of double its amount here. Okay. Alright. I thought you wanted to come closer to the sun. People number 3. Number 3 is on page 121. So here we tell the intraangle QRS. So QRS, that. We are told that SQR is equal to SRQ, which is equal to theta. Then we are told that QR is P, intra-angle, the other one, you got the theta angle there, you got 90, and you got SP, which is K. Prove that. Alright. So we start. They want you to prove that K is equal to something, so I start with K. You see that, people? So what you should see is a triangle looking like this. So this is 90 KP theta. So what must we use? We must use K and we must use SQ. Why must we use SQ? Because SQ is the link, yes, between the two triangles. Can you see that, people? So we say in triangle QSP. What can I say? Now I must use opposite and adjacent. Why can I use opposite and adjacent? Which is tan, but how come I can use that? How can I use tan? How come I can use tan? It's in a right angle triangle. If you got a right angle triangle, we use sine, cos and tan. Okay, if it's not right angle triangles, then we use sine rule, cos rule and area rule. You guys understand? Alright, so since Q is or is a right angle triangle, I can use tan. So tan theta equals opposite, which is K over US. And what I'm going to do is I'm going to make K the subject. Then naturally over 1 cross multiply. Therefore K is equal to QS tan of. But have I answered the question? No. So what must be replaced there? QS, definitely. Not so. And tan can be written as? And there's your sign. Can you see that, people? There's your sign. It will be over cos. So what do I do now? I look at the other triangle now. Say, okay? In triangle. This one now, what can we say? We have a length, which is QS, QR, sorry. You all agree I can calculate QSR in terms of theta. Okay, so we got that. We must pick up RS. Why must we pick up RS? The link between the two triangles. And we have a side here, which is theta. So which rule do you think we're going to use there? Sine or cos? Cos. Sine. Why sine? We have many angles. When do we use cos rule? We have two sides and included angle. Two sides and included angle. You could have two sides and included angle. You could also use the cos here. But it's going to be a bit difficult to make QS the subject of the formula. Okay. So now we got the triangle looking like this. Again, just make it a habit of redrawing, especially if you can't see. That is not what I'm supposed to be seeing. Okay. Here's your theta, QS, R, theta, P. Okay, so what do I say? In triangle, Q is R. I said we're going to work out angle is, not so. So Q is R is equal to 180 minus 2 theta. Why? Sum of triangles. Not so. Do I need to write this? No. There's 180 minus 2 theta. So what do I say? We want to make Q is the subject of the formula, not so. So Q is over theta, no. Q is over sine theta is equal to P over sine 180 minus 2 theta. So what I'm going to do is I'm going to reduce this using the reduction formula and take that up. Otherwise you can cross multiply. So QS is equal to P sine theta. 180 minus 2 theta. Which quadrant does this put you in? Second quadrant. Is sine positive or negative? Positive. So it's going to be sine 2 theta. You say, hang on. It's my friend. 2 theta. So sine 2 theta can be written as what? Or does the signs cancel? No. As much as you want to. Don't, no? Sine 2 theta can be written as what? Yeah? Come on, people, man. Say it. 2 sine theta cos theta. Not a oh, it's a theta, my girl. Don't you guys know this? Forgot? Yes. People, that cancels. Leaves you with what? That being equal to P over 2 cos theta. Whatever answered that question, that's what now QS is equal to. Have you answered the question? No. So what do I do now? You replace QS with P over 2 cos theta. You see that? So we put this into there. So I say therefore K is equal to QS, which is P over 2 cos theta, times, but tan can be written as what? Sin theta over cos theta, which is now equal to what? What's P times sin theta? P sin theta over 2 cos theta times cos theta. It's going to give you 2 cos. Okay. Something like this is probably worth 6 marks. 6 or 7 marks. Okay. Normally 2 there, 3, 5, 6. Say 6 or 7. Yeah, 6 marks. It's only if you want it. No? And most of us don't want it. You're right. Okay. Any confusion there? Go through it a few times. If you don't get it the first 3 times, try again. At the end of the day, it's going to be worth your while. Okay. There are, how many sums in this exercise? 3, 6. 6, okay, so I'm going to stop the video. And we're going to make it 3, 3. Okay. Otherwise the video is going to be too long. So I'm going to merge this with the previous day's lesson. Okay.